Hi guys, how we all doing? You're joining me today at a lovely lakeside resort out in the Highlands somewhere. I decided to break quarantine and have travelled northward to these serene surroundings. However, I would encourage you guys not to do the same. Definitely don't break quarantine. It's very, very naughty. I've not actually done that. But let's pretend we have, because it makes things a bit more interesting. How are we all doing today? I'm seeing that we've got 12 people viewing already, so we've got people that are in the chat. We've got Lucy, Freddie, Sky, we've got Michael and Callie, Emily. Good to see you all, guys. Hello, Issa, you're here as well. That's good. So, I've just realised I've got the wrong title for this video. I obviously used the same settings as last time, and that has scuppered me a wee bit. Let me see if I can change this quickly, because today is the 22nd of May, and it is not the first day back after the Easter holidays. The plan for today, which I'm going to type up in the comments just now, is we'll do a little bit of the class curiosity tree. We're going to talk a little bit about space and the topic that you have to do today, which is a comprehension activity. So I'll type up comprehension there. And lastly, we're going to have a little bit of a look at fractions in maths, because although you're carrying on with grid references today, and that's quite an easy thing to do, tomorrow we're doing tomorrow and Friday we're going to do a little bit of revision on fractions, so it'll definitely be worth revising some of that just to make sure that it stays in our head. So that is the plan for today. Before we get started though, how are we all doing? Anyone got any interesting news? Anything that's worth sharing? Remember that my feed is a good 10 seconds or so behind you guys, so if you type something, I won't actually see it for 10 seconds, so if it looks like I'm just gawking at the camera, not knowing what to say, then it's because I'm waiting for you guys to say something. So, any news from anyone? Anyone done anything interesting in the past 24 hours? Or before then, actually, if there's anything that you haven't said from the Easter holiday period, it would be good to know, because it's nice just to check in. We've got more people saying they're going on TikTok. Hit 100 followers. Woo, milestone. Cool, if it keeps you happy. We have someone whose dog got their vaccines. I hope your dog is doing fine. I'm a big dog lover. What else have we got? Yes, Aisha, I heard about this actually. Yeah, one of the shops underneath your house went on fire. I hope everyone is okay, and that hopefully the damage was minimal. But yeah, that's certainly stressful news, particularly given the circumstances. So I'm really hoping everyone's okay. And Megan has learned to do a back walkover, which is something that my spine would never allow me to do. I'm a fairly flexible guy, as you know. I can do the splits and stuff. Maybe not right now. I'm a bit too much sitting down these days. But I've never been flexible enough to do something like a back walkover. So that's pretty cool, Megan. Good effort. Anyway, let's start off then with a little bit of the class curiosity tree. Do remember that we're not wanting to the comments. If I ask you a question, you can respond to it, but don't fill up the comments with just random nonsense. I don't want anyone just being daft. Let's keep it all quite sensible. But class curiosity tree. Now, I'm not promising to be able to answer all of these, but I'll try and batter out a few of these fairly quickly. So I think we've already covered what is plastic made of, which was oil, basically crude oil is made from, and why is the Earth round. We talked about how gravity is a force that pulls everything to the centre, so if one side gets too big, that'll be pulled down, and other things will be pulled more towards that side, so overall we get a round shape, or what's called an oblate spheroid, usually. What one will we do now? We talked about what was the first type of dog as well. The answer to that was a wolf. Just now, let's go for... there was one I saw earlier that I wanted to do, but my computer keeps jumping around. How do trees grow from such a tiny seed? Well, to start off with, seeds are basically just stores of energy. So they have a lot of what's called carbohydrate in them, and that gives an initial burst of stuff just to get that tiny little seed to the surface. That first little green shoot getting to the surface. However, as soon as it gets to the surface, the seed's job is kind of done. So the energy in the seed only needs to be enough to get that green shoot to the surface, because as soon as the shoot gets to the surface, that then means that photosynthesis can start to happen. Now, photosynthesis is how plants take light and turn it into energy. Basically, they turn it into their own food. So as soon as the shoot gets past the surface of the earth, it can then start making its own energy and start growing upwards. So actually, seeds don't need to do much; they just need to be enough to get that shoot going upwards. Why is grass green? Tying into that, because of a chemical called chlorophyll. Chlorophyll is the chemical that's used by plants to photosynthesize. And that basically allows it to trap sunlight and turn it into energy. So chlorophyll is that chemical. This one's quite complicated to answer, but why does it rain in some places and not others? So it's to do with air pressure. But why do we have... so basically, if you've got more pressure... I always get it the wrong way around. I'm not... you need to verify this. But I think more pressure means it rains more. Less pressure means it rains less, I think. It might be the other way around. I always get that wrong. However, basically it's to do with how... think about how heavy the air is. That's what causes it to rain. However, what causes differences in air pressure is to do with unequal heating of the Earth. So the Earth is a really, really big thing, and it's an irregular shape. It's a spheroid, and so parts of it get heated more than others. So down by the equator, it'll on average receive more sunlight. Up where we are, on average, we receive less sunlight. And so because of that difference in heating, we get what's called convection currents. So here's a wee experiment you can try. If you... oh, what would it work with? I think I've seen it done with something like glitter before. If you put glitter in hot water, you should notice that the glitter will sort of float around in it a wee bit, and you might see it following a particular path. I'd need to look up the exact way that you do it, but it's something you can look up online. So they're called convection currents, and it's basically to do basically hot stuff rises more than cold stuff. So when you get heat, you get things going upwards. When they get cold, they go downwards. On the scale of the whole planet, that means that some places are pushing pressure upwards, some places are pushing pressure downwards, and all this sort of stuff, and that's what causes differences in weather from place to place. Why do we get sore ears on a plane? Also to do with pressure, so that ties in as well. You have a little air pocket inside your ear. Whenever you're going up, the air is thinner up there, there's less air up there, and more air inside your ear, and so the air tries to expand so that it matches the pressure outside. What's worse than that, though, is if you dive underneath the water. If you try diving down, you might notice that it starts to get quite painful. And if you go deep enough, you could actually rupture your eardrum, because what happens is all that pressure, all that water, which obviously weighs a lot more than air, it starts to squeeze on your ears, on that little ball of gas in your ears, and that can become quite painful. So that is basically why we can get sore ears in airplanes. Anyway, that I think is enough of the class curiosity tree just now. We've spent a few minutes on that. So next thing is the topic of space. So space is going to be our topic for the next while, and hopefully some of you have already seen the Big Bang video that I've put up. That is what your work is going to be based on. Give me a thumbs up or something in the comments if you've already seen the Big Bang video. If you haven't, definitely go and watch it because it is fantastic, I think. I mean, you know, I spent a long time on it. I put a lot of love into it. So please go and watch that and then do the comprehension questions on it. Now, the comprehension questions are color-coded. The green ones are slightly less challenging. That's just to do with remembering stuff that was said in the video. The orange ones are slightly more challenging in some ways. And then the red ones, you have to kind of do a little bit of thinking to answer some of the red ones. So yeah, definitely go and watch that. I've tried to make it as accurate as possible while still simplifying it enough to be understandable to you guys, because the whole idea of the Big Bang is actually really complicated. There's a lot of evidence. Well, I mean, we basically know it happened. It's just a question of how it happened. But I couldn't go into all the evidence in the video, partly because I don't know all the evidence, but I know enough of the evidence to explain it. So if you want to know any more about it, feel free to ask at a later date. So that is your comprehension activity today. So make sure that you are doing that, and that is how we are kicking off our space topic. Now, in terms of the space topic generally, we're going to be doing lots of other things. So we're starting off with a Big Bang. We're going to talk a little bit about stars, learn what a star is and what are differences between stars. That'll probably come a bit later, actually. After the Big Bang, we're going to start talking about planets. We're going to get to know our own solar system, our own galactic neighborhood, if you like. Learn a little bit about all the different planets, and you will hopefully learn that pretty much every diagram that you have ever seen of the solar system is wrong. Massively wrong. Horrendously wrong. Which I think is kind of cool in a way, and actually teaches us a lot about space by learning just how wrong every diagram we've ever seen is. So that's one thing that we're going to be examining. We're going to look a little bit about stars, a little bit about constellations, so different collections of stars that in the past people thought made different shapes, and we're going to learn why some of those can be useful. We'll investigate galaxies, which are huge collections of stars. We are in a particular galaxy. 10 points to the first person who can type the name of the galaxy that we are in. But galaxies are basically collections of billions of stars. So, I mean, a billion is a phenomenally large number. So, a million is quite... Here's a way of thinking about it. A million seconds is, well done, we've got people saying the Milky Way there. First one up was Nathaniel, so we live in the galaxy called the Milky Way. Anyway, just to give you a difference, an idea of the difference between things here. A million seconds is 11 days. That's quite a long time. If you had to count 11 seconds, if you had to count a million seconds, that would take you 11 days if you were doing one number a second. 1, 2, 3. 11 days of constant counting. A billion seconds takes 31 years. 31 years just for 1 billion. I think that is astonishing. A billion seconds, 31 years. Now, our galaxy contains 100 billion stars, just like our sun. Some a bit bigger, some a bit smaller, but 100 billion, roughly, stars just in our galaxy. And if you've watched the Big Bang video, you'll have also come across the fact that there's a whole lot of galaxies in the universe. I mean, this is just mind-blowing stuff. So, to count 100, so if 1 billion is 31 years, to count 100 billion, that'd be 31 times 100. That's 3,100 years just to pass 100 billion seconds. I mean, it's mind-bending. And of course, the distances between each star is absolutely gargantuan. But anyway, sorry, you can see I'm getting a bit enthusiastic about it. I love this stuff. I just find it so mind-meltingly wonderful to contemplate. But before I get too excited, I'm going to cut myself off now. But I think that's pretty cool stuff. Anyway, that's space. These are the numbers that we have to try and wrap our head around. And The reality is our minds aren't capable of it, but it's pretty fun to try. Anyway, that's space for you. The last thing we're doing then, so we're only 15 minutes in. I'm probably going to be making this lesson a little bit shorter depending on how we do with the next section. But we're now going to look at fractions. Now, if you feel totally comfortable with fractions, if fractions is absolutely your thing and you just sort of think, yeah, you know, that's no problem for me at all, that's absolutely fine. However, if a couple of you are sitting there, and I know you will be, and that's okay, the point of this is it's revision. If some of you are sitting there thinking, you know what, fractions, I get a bit confused, what do we do, there's division, there's multiplying, there's all this stuff, well, that's what this section's for. This is basically for you, okay? So let's take a little bit of time now to look at fractions. And I'm going to change my screen, and we are going to go to our flip chart here. Excellent. Right, and if I come over this side, that should be a little bit better. Right, so we're looking at fractions now. Now, fractions, all fractions are basically division. If you know how to divide, you know how to do fractions. So in this case, we're being asked to find 1/3 of 12. Well, what does that really mean? It really means 12 divided by 3. That's all a third is. Take 12 and then divide it into 3 equal parts. Now, if you know your 3 times table, you can do that really easily. Count up in 3s until you get to 12. We get 3, 6, 9, 12. What's the answer? 4. But let's say you didn't know your 3 times table. You can still do it. You can do it diagrammatically, using a diagram. So I've got 12 wee dots here. I'm going to share it into 1, 2, 3 equal piles. So when I do that, and you know what, this is going to take a while of me clicking back and forth. Well, what we should find is that we get a total of 4 dots. Oh, I accidentally shrunk those ones, that's annoying. We should get a total of 4 dots in each section. So what we've just done is we have divided 12 dots into 3 equal groups. Hopefully we all follow that. So 1/3 of 12 is 4. And I'm seeing lots of us answering that in the comments, which is excellent. However, what if, and this is our learning intention today, we're learning to calculate fractions of a whole number when the numerator, the top number, is greater than 1. So what if we had to work out 2/3 of 12? What would we do there? Well, we know that 1/3, let's get our highlighter here, 1/3 is that, basically. It's 4. So 2/3, well, that's going to be 2 lots of it. How many have we got? Well, it's 8. So what effectively we're doing is we're doing 12 divided by 3, which was 4. And then we are taking that 4 and we're multiplying it by, oh, that's a horrible circle there. We're multiplying it by the top number, because that's the number of groups that we're talking about. So we're splitting it into 3 groups, and then we are taking 2 of those groups. And so we get the answer, 8. Hopefully that makes sense. So effectively, divide by the bottom, times by the top. And I know some of you know this, but it's good to revise it, and it's something that some of us need to revise. So let's look at this example then. We got 1/4 of 16. 1/4 of 16. Well, what number are we going to divide by first of all? We should be thinking, what number are we dividing by? And straight away in the comments, I should be seeing you coming up with 4. Absolutely, we're dividing by 4. So we're going to divide it into 4 equal groups. Or effectively what we've done is 16 divided by 4. This is very awkward writing like this because I'm having to do it using my mouse. I haven't actually got my pen to write with. So if we do that, what we should get, we're splitting it into 4 equal groups. Now I'm just doing it quickly here. If you didn't know how to do it, you would just do 1 dot at a time. But we share it into 4 equal groups. And again, in this case, 1/4 of 16, once again, is 4. Same as the last one. So 1/3 of 12 is 4. And 1/4 of 16 is also 4. But what I want you guys to work out, in fact, let's write this down first of all, 16 divided by 4 is 4. But what I want you guys to work out is 3/4 of 16. So not just 1/4, but let's highlight all of this here. 1, 2, 3/4. So we're going to basically take this 4 here and multiply it by 3 here. Let's highlight them here, the two numbers that we're going to multiply together. So we divide by the bottom, which was 4, and then multiply by the top number, the numerator, which is 3. So 4 times 3, and our answer then is 12. Okay, so that's kind of, and I've just come back to the chat and I've seen the chat is utterly brimming with the answer 12 there. So it seems like most of us get this, and maybe I'm flogging a dead horse. Maybe this is stuff that we all get absolutely fine, but like I said, I really like going over this stuff to make sure it's fully embedded in your head. However, what we could do, I'll tell you what, I'm gonna come back to the full screen just for a minute while I tinker with something here. So let me just go to the next example. In fact, I'm going to create a new example for us. This one is a bit more challenging. Not super challenging, but a bit more challenging. Let's do 10. Sorry, I'm not going to read it out loud just now. There we go. Okay, this is me just having quickly knocked it up here. Let's go back to Active Inspire. There we go. So, this one is a little bit different now. 10/25ths of 30. Now, I look at a fraction like that and I think, well, that's a rubbish fraction. That fraction ain't handy. I don't want to divide by, I certainly don't want to divide 30 by 25. That's really hard. So what our brain should immediately be thinking is, in fact, I'm hoping someone in the comments is going to tell me, what should our brain immediately go to when we see a fraction like that? Simplify. Thank you, Miss Hamilton Nickel there. Yeah, we want to be thinking, simplify that. So 10/25ths, that fraction sucks. It's rubbish. We hate fractions like that. Simplify it. And I could see Nathaniel straight away in there saying 2/5. Now, both of these are in the 5 times table. Everyone always thinks with simplification we just half things, but actually we can't half 25 here. What we can do is divide them both by 5. They're both in the 5 times table. So how many 5s are in 10? 2. Oh, horrible 2 there. How many 5s are in 25? 5. So 10/25ths of 30? Nah, what it's really asking us is 2/5 of 30. Well, that's a whole lot easier. That's miles easier. We use our strategy, divide by the bottom, times by the top. So let's do that over at the side here. What are we doing? We're doing 30. Just making sure my computer's still live here because I heard a weird noise. There we go. Nope, we're fine. We're still live. 30. And we're going to divide that by 5. The answer to which is 6. But then we need to take that 6, which is 1/5, and we're going to have to multiply it by the top number here, which is 2. 6 times 2, and the answer is 12. So that's basically everything that you're going to need to know for the next wee while. A couple of the ones on Friday are going to be a bit more challenging. They're a bit more word problem based, or at least for those of you that take on the hotter options, they'll be more word problem based. However, if you're taking on sort of the spicier stuff, this is the most that you'll need to be able to do. You'll need to be able to do a little bit of simplifying, and then a little bit of doing the fractions, divide by the bottom, times by the top. give me a thumbs up or a yay or a woo or a I love maths or something if you feel like this is okay with you. At the same time though, give me a I'm unsure, or let me know if there's a problem as well, and maybe I can try and get you on Teams later and see if we can patch up things a little bit. My key with division, the one thing I'll say about division here is just make sure that you're completely comfortable with your times tables effectively. So if you're divided by 5, you do your 5 times table until you get to the number that you're looking for. If you're if you're doing a third of something, you're dividing by 3. If you're doing a fourth of something, you're just doing your quarter even. You're just doing your 4 times table until you get to the number you're looking for. Okay? If it's division that's tripping you up, times tables is your key. You need to embed those times tables in your head. Okay? Right, guys, so that's the lesson content. For my class, one thing I'm wanting to do, I'm gonna run a quick Teams meeting just now, just so that we can converse with each other, because I'd like to put in a strategy in place where we can get together groups of us. So we'll go into Teams basically when we sign off of here and just have a very quick chat, 5 minutes ish, and then figure out how we can meet up to check in with each other a wee bit more. But for now, thank you for tuning in to this live stream. I'm signing off now. In fact, let's go back to our lovely surroundings before I do so. It's slightly glitchy over here somewhere. That's annoying. I'm new to green screens, but it's a bit of fun. Anyway, signing off now, guys. Thank you for coming along, and work hard today. See you soon.